Albatrosses live by memory and return, coming back year after year to breeding islands where terrain and wind make takeoff, soaring, and landing possible. A dense colony is not only a nursery, but a collective alarm system. One warning call ripples like a wave and hundreds rise into defense. Each bird must recognize its own place in the crowd, because losing the nest means losing the egg, and losing the most valuable currency of the season, time. Even small errors matter here. Arriving late, choosing the wrong corridor, or provoking a neighbor can drain energy before the first egg is ever laid. On this island, survival begins as logistics. A nest site is an engineering decision. Too close to the edge and gusts can roll the egg or send a bird sliding. Too deep inside the colony and collisions, conflict and stress rise. Distance to the sea is an energy cost. Every extra meter means the chick waits longer between meals. Albatrosses optimize by experience, selecting a spot that breaks the wind yet leaves a clean launch path and a clear view to spot squaws early. A good nest shortens risk and stretches survival. It also reduces heat loss, because the wrong exposure turns incubation into a battle against cold air, not just predators. In a place ruled by wind, centimeters can decide a future. In a crowded colony, pairing can't rely on luck. Albatrosses use ritual to find the right partner. Posture, call, rhythm, spacing, and synchronization become a precise language. It tests compatibility, because raising a chick is a long project, requiring smooth incubation shifts, guarding, and endurance through storms. They aren't choosing a moment of romance. They're choosing a teammate. Someone who stays calm when a skua appears and keeps the return schedule steady across an open ocean. These dances also reinforce recognition, so months later, after long foraging trips, the pair can reunite without hesitation. In the noise of the colony, identity is built through rhythm. In a colony, injury is the highest price. A torn wing can end the season because the bird can't range far to feed. So many fights are fights of control. Who holds position? Who stays composed? Who forces the other to retreat without paying in blood? Females watch closely, because choosing a partner means choosing nest defense for the entire long season. In strong winds, the one who stands firm is often the one worth trusting with the future. And the colony notices too. Repeated losses can push a bird to poorer ground where storms hit harder and skuas patrol closer. The social map of this place is written by tiny victories and safe retreats. An albatross nest is a windproof design. A raised rim prevents rolling. A deep cup holds warmth. Compressed material keeps structure when rain softens the ground. The pair works like a small assembly line because they lay few eggs and cannot afford mistakes. Once built, the nest also becomes a social boundary, where any intrusion triggers an instant response. A strong nest protects not only the egg, but the rhythm of the pair's entire season. It also cushions the egg from vibration when storms shake the colony and gives the incubating adult a stable posture that saves energy over long hours. In this environment, building is survival. For many albatrosses, one egg is the whole season. The embryo needs stable heat, and even a few minutes exposed in cold wind can affect development. The handoff is a test of timing. Fast, precise, never leaving the nest open. A skua doesn't need to be stronger. It only needs the right second. Parents must incubate and watch the sky at once, because danger often arrives from above when everything seems safest. The guarding adult also manages space, keeping neighbors at a distance to prevent accidental bumps that could crack the egg. Here, parenthood is measured in minutes and in temperature, not in sentiment. Extreme weather creates gaps in the system. A delayed handoff, a flight path bent by gusts, nests shaken out of alignment. The skua exploits chaos because one exposed nest is enough. But the colony is collective defense. When one nest is threatened, reaction spreads fast, and Rob is the raider of surprise. Here, survival is organization. The bigger the storm, the clearer the value of nesting at the right distance from neighbors and keeping strict discipline through every handoff. In these hours, even adults can lose body heat quickly, so the group's stability matters as much as any single pair's courage. When order holds, predators hesitate. Hatching is only the start. Feeding is the heavy part because food lies offshore. Albatrosses exploit wind to travel far at low energy cost, seeking waters where dolphins and tuna herd prey to the surface. Each trip is a balance. Farther may mean richer prey, but the chick waits colder and hungrier longer. So the ability to read ocean signs and navigate wind corridors sets the schedule of the nest. The chick lives on warmth under wings and on the parent's punctual returns. Early on, meals are small but frequent because the chick's body cannot store much energy yet, and missed timing quickly becomes weakness that attracts attention from raiders. First flight is pure physics. Wing angle, airspeed, and the exact moment the wind becomes a lifting partner rather than an opposing force. What looks like instinct is actually rapid learning. The chick tests the limits of its wings in short bursts, then longer runs, discovering how to brake by opening the wings wider, how to stabilize by lowering one wingtip, and how to turn without bleeding too much speed. In strong gusts, the margin for error is thin. A misjudged angle can stall the bird. A late correction can slam it toward the slope, and even a small injury can reduce its chances of surviving the first weeks at sea. Leaving the nest happens before the chick feels ready, because the ocean does not offer extended rehearsal. Once offshore, survival becomes navigation. The bird begins building an internal wind map. It learns that headwinds cost energy, tailwinds stretch range, and certain patterns of swell and spray signal where the air is more stable. It also learns to read the water itself slicks. Surface flashes, and the behavior of other seabirds can hint at prey beneath. But the ocean is a moving puzzle. Prey fields shift, storms rearrange routes, and predators patrol open water where there is nowhere to hide. The chick's early days are therefore a sequence of decisions. When to push farther, when to conserve, when to follow words, and when to avoid a risky zone. And yet, albatross life is not only about distance, it is about return. As the bird matures, memory anchors it to a birthplace shaped by wind and rock. Years later, the same air currents that carried its first glide will guide it back to this breeding island. The crowded nesting ground, once overwhelming, becomes a familiar map of sounds and silhouettes. The cycle closes not with an ending, but with a homecoming, because returning is how the next courtship season begins. From that first leap, the world expands from a few meters of pebbles to an endless moving ocean, where survival depends on judgment, patience, and the ability to ride invisible air with precision.